Okay, so this is criterion B question. So a group of students are investigating the effect of crumple zones in cars, and they use the cardboard to model the main body of the car. Let me show the diagram. They use foil paper to model the crumple zone on the front end and use them to launch them using a rubber band launcher as shown in the figure. Okay, so the rubber band launcher they use, and this is the crumple zone they have modeled using the cardboard, and they pull this across, and then as a result of it the car moves forward and goes and hits a wall. And what we are going to vary is we are going to increase this length of this crumple zone. Okay, then and find out what is the effect of it. Okay, so this is what is the interest. State a possible research question for the investigation and explain it using the scientific reasoning. What is the possible research question for this one? So what is the possible research question? So you can just ask, how does the length of the aluminium foil crumple zone okay, in centimeter, maybe you can put this in bracket also, affect the distance the car rebounds after impact. Okay. So see, how does the length of the aluminum foil that are attached to the crumple zone affect the distance the car rebounds after impact? This will definitely give you a better question to investigate. So when you have a larger aluminum foil, then the shorter could be the car rebound can happen. Okay, we can put it across this one. Now, next, formulate a possible hypothesis, justify it using scientific reason. Now, first one. So how do you write down here? So that's what we have already given this one here. You can just say if the length of the foil crumple zone increases, then the rebound distance of the car will decrease. Now, if you write only this much statement, you will get only 1 mark. Okay. So what is that you need? You need to explain it also. You need to justify it using scientific reasoning. So how do you justify it? So what is the justification? You can say the foil. Now what happens to the foil? The foil acts as an energy absorber. It acts as an energy absorber, and when the car hits the wall, then what can happen? When the car hits the wall, the kinetic energy is converted into work. The kinetic energy is converted into work done to deform the coil, right? So therefore, if you have a longer crumple zone, as I a longer crumple zone. If you have a longer crumple zone, this will give you more deformation. Okay, and so when you have a more deformation, this extends the time of collision. When you have more amount of time of collision, what can happen? So as a result of it, so it absorbs more kinetic energies, and at the same time this results in less energy remaining for the bounce back. Therefore, bounce back energy reduces, and hence Distance also reduced. Distance also reduced. Okay. Now let me move on to the next one. So this question just eaten up the space, but anyway, okay, we can write here. Then select and explain the independent variable, dependent variable, and control variable. Right? What could be your independent variable? Independent, what is it? So you are varying the length of the crumple zone. You can say length of the crumple zone measured in centimeters. Okay, so this is what is your independent variable. Now what's your dependent variable? Dependent variable would be rebound distance of the cut after collision. After collision, you can mention this also. Then what is it you need? Control variable. What's the control variable? Control variable should be mass of the car. Mass. Because when you have, he is also asking about explain. You need to mention here. Okay. So mass of the car. So a heavier car will have a larger momentum. Okay. So see to it that the momentum is kept constant. So mass of the car should be kept constant. Okay, if you want, you can write here. You can write a heavier car has higher momentum. Has higher momentum. Therefore, the cardboard body and the wheels should be the same. That is one of the variables. Second variable is, see, when you have the car, for example, if you go back here, when you have the car and you are pulling it out, so every time you should pull it by the same distance. Okay? Because one time you pull it by less distance, sometimes you pull it by larger distance. What can happen is the energy given to the car for its motion, it doesn't have any battery over there. Which energy it is getting? It is getting an elastic energy, right? The elastic energy of the band is given to this. This elastic potential energy of the band, elastic band, should remain the constant. Okay. If it has to remain the constant, then the pulling length should be the same, right? So you have to write that also. That should be a constant. The elastic band should be pulled by the same distance every time. Maybe you can say 10 centimeter, for example, I'm pulling it. Okay. So to ensure, so why do we need this? So that we can see to it that to ensure the initial potential energy and velocity, initial potential energy and velocity is constant. Okay. Then you can also put one more. You can also put friction, because if the friction is different, then automatically you will not get the proper answer. So how do you do this one? So it should be conducted. The experiment should be conducted on the same Okay, so that surface friction remains same. Okay, I think you asked only for two. There's one three over here. Then design a brief and safe procedure in the text box along with a logical observation table. Should be there. Okay, so you need to design a brief and safe procedure. Actually, it can be split into two parts. But anyway, so since I put it for 4 marks, I put it into one of them. Anyway, let us do this. So first one is what do you do? To maintain a track. Okay, so you keep an appropriate track for the for the car's movement. This is the first thing that we need to look at. And secondly, what we need to do, uh, set up a rubber band launcher. Set up the rubber band launcher fixed at one end of the track, fixed at one end of the track, and yeah, and then after that, construct a standard cardboard model so that the width of the car should be slightly smaller than the width of the track. Okay, so this you can decide. Okay, so usually if I am doing this one, what I will do is I'll always see to it that the width of the car, if it is 5 centimeter, I'll keep the track to be 10. See, I can have a friction, but it should not be so tight that it goes and collides over here, unable to move on. So at least something like this we need to do. Then what's the next thing? So we have designed the car, we have designed the track, we have designed the launcher. Next, very important thing is you have to attach a crumpled foil, right? Long crumpled foil. How much long can it be? Now you can attach a 2 centimeter long crumpled foil. Crumpled foil cone. It should be like this. It should be like this over here. So this is the car that you have. The car that you have. You can keep it like this over here. So it goes and hits over here. The old, I think, Buster Keaton movies, if you see, so the old trains will be having something like a slope like this. It goes on. Okay, so even if it hits someone, okay, nothing will happen. Something like this. He makes this fence over here. So in a similar way, okay, this is what we can do. And go to the front, attach a 2 centimeter long crumpled fine cone to the front of the car. Then now all the construction part has been done. What's the next step? Release the car. Pull the band. Pull the band. Pull the band. Pull the band. No. Pull the car against the rubber band. Rubber band to a mark. To a certain mark. Maybe you can say 10 centimeter back. 10 centimeter backward. Then what you should do? And release the car. Release the car. Now, fix one. Once you release the car, what will happen? The car will start moving after and will stop at some point, right? So wait for it. And the moment it stops, measure the distance traveled by the car. The distance traveled by the car using a ruler. Using a ruler. Then, seventh point, you can say repeat. Which step I can say repeat repeat steps 5 and 6. 5 and 6. I'm not going to repeat the previous ones, right? 5 and 6 for each length of the crumpled foil length and tabulate. Repeat 6, 5 and 6 for each length of the crumpled foil length for 3 times. It's very, very important to reduce the random error, random error. Okay, this is what you need. Finally, um, do the experiment for various lengths like 2 centimeter, 4 centimeter, 6 centimeter, etc. until 10 centimeter. Okay. Instead of various lengths, be specific for at least 5 lengths. Okay, starting from 2 centimeter, 4 centimeter, 6 centimeter, 8 centimeter, 10. And after this safety required is given here. It's a logical, safety is asked. Okay, safe procedure. You should write the safety. What are the safety measures? We're not using any heat experiment here. Therefore, there is no need of any tongs or maybe a fork and so on. So you just need safety goggles. Safety goggles protect eyes. Protect eyes. Why do you want to protect eyes? Is there a chemical? No. But the moment you are snapping this one, there's a possibility the rubber band can come and hit your eyes, right? Because if it breaks, then there's a possibility it can come and hit your eyes. Goggles to protect eyes from snapping of the rubber band. You can mention this. Okay. Then finally, you need a table. Now, what is the table here? Table looks like this over here. You can say length of crumple zone in centimeter. Then what you can do? You can say the moment the length is being done, then you have distance, rebound distance, rebound. Is it rebound distance? Yeah, rebound. Rebound distance in centimeter. It would be trial 1, trial 2, trial 3, and then let me say this is your D. Then you can say D average in centimeter. Okay, that's it. Okay, if we do so much, I think it's more than sufficient. So with this we come to an end to this particular problem. And we see criteria 2 tomorrow.